Okay, today we will be discussing about our transit gateway. So, what is exactly a transit gateway? First, we need to understand about a transit gateway. Before understanding a transit gateway, just can you all confirm that you are clear with VPC pairing? So, what is a VPC pairing? So, we have done different diagrams here. We have done different labs. So, our first lab on VPC is nothing but we used to use a one subnet, one VPC, and in one VPC we used to have two different subnets. But in a second lab we have done multiple VPCs and with different subnets. So today we will be doing. Yesterday we have done with two VPCs. Today we will be doing about three VPCs. So what is the difference of doing a VPC instead of going for a transit gateway? Why we are using a transit gateway, and what are the advantages of a transit gateway? So before going in jumping into the transit gateway, let me explain you what are the drawbacks of VPC, where our transit gateway comes into a picture. Okay, this is a diagram which we have done yesterday. So I will be doing a new one. So here, this is my AWS network, and within the AWS okay, and within the AWS we are using our
Pediu passo no Twitter?
so okay, let us take here. So this VPC, this is a one VPC, and this is another VPC. If we have a two VPCs, okay, that's fine. So we two VPCs will be fine. Like we create. Sorry, I have not shared my screen. No display, sir. Shall Okay, okay, sure. That's what we will do it. Okay, not an issue. I am reviewing the same topic of yesterday. Then we will have. Let me share my screen. So sorry, I have missed and presenting my screen. Okay, sharing my screen now. Okay, here in our lab, what we did yesterday. This is our AWS. This is our AWS, and this is our VPCs, right? These are our sorry VPC -01, VPC -02. So this is the two VPCs which we have created yesterday, and within the same AWS region we have created two VPCs, and we have created two subnets under the VPCs. This is our subnet. These are our subnets. Okay. Okay. So this is what we created yesterday. Orange one is nothing but a subnet. and green is one my AWS region. This is like my VPC. Sorry, VPC. This is subnet. This is my region. Green one is my region, and this is my VPC, and this is my subnet. So inside the subnet, we have created our EC2 instances. Okay. Till here, is everyone clear? Just please respond on the chat. If you have any doubts, just respond very quickly. Okay. So Sayed, is it clear till now here? Till the diagram I have explained? Okay. So right. So now this is two VPCs and two subnets and two EC2 instances. Okay. And now what we used to do is we used to create a IP address here saying as 10 dot, for example, let us take 12.0.0.0 by 16 for this VPC, and for this VPC we are using 13.0.0.0 by 16, right? So we are using two VPCs. I am naming this as a public hyphen VPC, private hyphen VPC. Okay. Day before yesterday, we created only one VPC, and under the one VPC, we have created multiple subnets. But yesterday, we have created two different VPCs, and within the two different VPCs, we have created two different subnets, and then we have created the EC2 instances in that. Okay. Now then, to communicate, to have a communication, what we did is we have created a router over here. Okay. We have created a router, or which we call as route table, router or route table. What is this route table is doing? So we have created a route here which contains the subnet. So here we have created like 10 dot, sorry, 13.0.0.0 by 16. This is on one route table which is called as private RT. private route table. In the same way, we also created a one more route table 12.0.0.0 by 16, that is called as public hyphen route table. To get access of this EC2 instance, we have created another gateway which is called as which is called as internet gateway. So this is our internet gateway. What happened? This internet gateway is connected with this subnet. This internet gateway is connected with this public subnet, so that whenever I want to access a EC2 instance, which is under public VPC, so I used to connect the internet gateway, and from internet gateway I used to connect to public VPC. How my internet gateway will understand where to route? So that's the reason why we have written a route table. We have updated the route table by mentioning that 0.0.0.0 public RT. In that public RT, I have mentioned as 0.0.0.0. Okay, that need to be destination to my internet IGW internet gateway. Then next I want to establish a communication between 12 and 13. So I have provided the destination of a 13 address, and here 13.0.0.0 by 16, and here I have given my peering. So I have configured the peering, and I have given the peering address. So here, to have a communication between my one VPC to another VPC in a route table, I have provided this route details, so that my public subnet or public VPC will establish a communication between 13.0.0.0. Means I can start communicating to the another EC2 instance which is on VPC 02. Is it clear? Is it clear with everyone? Okay, right. So till now we have updated our public RT. Now I will be creating my private RT. Where I am not going to give any internet gateway over here. Why? Because I will be communicating with my local machine. So here I am adding a route called as 12.0.0.0 by 16, and that too I will be using a pairing. Right. So here you have a public route table and private route table. Private route table is specifying your destination to 12.0.0.0 by 16, and public route table is specifying a destination with 13.0.0.0 by 16. So this is fine. Now I can access to my EC2 instance through an internet gateway, and from EC2 instance there is a route established, a pairing connection established. So between these two I have created one pair. Okay. That is what pairing I did. So between these two VPCs, I have configured a peering. So based upon the peering, my two VPCs start communicating. Okay. Till here it's clear to everyone. Okay. Yes. So till here it's clear, right? Everyone has understood. Sayed, is it clear with you? Okay, fine. Thank you. Now there are some limitations on VPC pairing. So what is VPC pairing? VPC pairing can communicate or can establish a communication between one to one, means one pairing to means one VPC to another, means this is A and B can communicate. But let us take as another fashion. This is called as A. This is called as B. Okay. This is called as B. Now A and B can communicate. But let us assume in my organization I have created a one more VPC. Okay. I have created a one more VPC called as C. This is a one more VPC which I have created in my environment. This is called as C. So what I want to do now, if I want to go with VPC pairing, so again I need to create two different routes. One is this one. I can take this line. I'm not. Okay. So B to C. I can create a pairing between B and C. So now A and B can communicate and B and C can communicate. Can A and C can communicate? So if I want a communication between A to C, I need to create a one more pairing in A and one more pairing to the C. Okay, 3 is good. If I say, if I have some around 30 or 40 VPCs, okay, if I have 30 VPCs, is it very much difficult? You will be getting very much difficult so to establish a communication between multiple VPCs. To overcome this thing, we have introduced, the AWS has introduced a transit gateway. Transit gateway is act like as a central hub, which will be acting like as a central hub for sharing the data. Here, when you configure the transit gateway, you does not require a pairing connectivity now. So you does not require any pairing connectivity. You need not to configure any pairing connectivity. Just you need to configure a transit gateway. So transit gateway will communicate with multiple VPCs. So just you need to create an attachment from one VPC to another VPC. Like here I can use a transit gateway. So here I am building a transit gateway here. Let me take this as my transit gateway, for example. Okay, here I need to build an attachment from this, to this one, and from this VPC to this VPC, and this VPC to this VPC. That's it. So you need to build a attachment on a, this is my a transit gateway. So this is my transit gateway. Here I will be configuring a different VPCs, and that VPCs will start communicating. So today we will see how the transit gateways works, and just have a small presentation of transit gateways. And is it clear with everyone? So the advantage of a transit gateway. Minimum, like as per the limitation, you can have a maximum 5 VPCs per region, but that can be extended based upon the requirement. So if my company require more VPCs, then we need to ask our AWS service provider. They will extend our limits, but the default limit is 5 per region, but that can be extended based upon the requirement. And in one region you can create up to 200 subnets. Yes, that's correct. That's correct, Wahid. So if you are using more than 2 VPC pairing, so is, if you have more VPCs, then you will be using a transit gateway, which reduce your load and which reduce your cost as well. And the data transfer also will be very fast. Why? Because the data transfer between one VPC to one another VPC, if you have created a transit gateway, it will be transferred through a AWS backbone line, AWS backbone connectivity line from one region to another region. So yesterday we were trying to do some one region to another region connectivity, but it's not happening. Why? Because there should be a transit gateway between one region to another region also. If you are creating any peering connection between one region to another region, there should be a transit gateway. That transit gateway will allow you for the pairing connection as well as VPC. So transit gateway, by using a transit gateway, you can establish a communication by using a VPC, or you can call as a VPN, or you can call as direct connect, or you can also use for your pairing connection. For example, let us take you have in this example only, this the VPC C is in different region. Let us assume that VPC C is in different region, means at that point you need to create a pairing connection between one region to another region, and the traffic will be routed through a transit gateway. So you also need to configure a transit gateway as well as pairing connection, so that the pairing connection will establish a communication link between your one region to another region. Okay, and next is your direct connect. What do you mean by direct connect? Direct connect means if you have your on-prem environment, which in that on-prem environment you want a communication from on-prem environment to your VPC, then you need to configure your direct connect connection, which is transit gateway direct connect connection. Okay, that I will show you where you can select that at the time of creation of transit gateway. Okay, so transit gateway will helps in multiple ways, like it will be helps in communicating with a centralized hub for VPC and centralized hub for VPN, virtual private network, as well as its centralized hub for your pairing from one region to another region, and it also use a direct connectivity. So these are the major advantages of a transit gateway, where the transit, that's the reason why we are using the transit gateway in our large environments. So let's have some so transit gateway is like a central hub that connects on Amazon virtual private network and on-prem networks, means VPC and on-prem you can connect, and data is encrypted automatically and travel within the AWS global network backbone, and it's a centralized connectivity. It serves as a single point of connection between your VPC data centers and remote offices, eliminating the needs for direct to VPC pairing or manual VPC configuration. You are not required to configure VPC pairing, or you not required to configure a VPN configurations between two different VPCs, and it's high scalable with the ability to scale to support thousands of VPCs and VPN connections. You can see here thousands of VPCs are scaled by using a transit gateway. Transit gateway is designed for a large and complex networking environment. If your networking is in a complex way, then it's easy. It will reduce your workload by using a transit gateway, and for the large network, we will be using as a transit gateway. Simplifies the routing. Transit gateway provides route tables to efficiently manage traffic between different connection resources without the need of manual updates of routing configuration. You need not to update your routing configuration every time. Just you need to create a routing table, and then it starts working. Okay, so there are few of the components of a transit gateway. So transit gateway is a main. So this is a centralized hub where all the connection resources, including VPN connections and on-prem networks, communicate. It act on routing center, facilitating traffic between attached networks. So attached networks, what are the attached networks? Transit gateway attachments. These are the connections between your transit gateways and various network resources. Attachment can be VPC. You can see attachments can be your VPC, your VPN, or AWS direct connect gateway. And here we need to add one more point. VPC pairing also can be an attachment. So transit gateway route table. So route tables are used to define how traffic should be routed between the attached networks. So we will be by using a bus. First we will be creating a transit gateway. Then we will creating a transit gateway attachment. Then we are creating a route tables. Okay. So that route tables will define how the traffic will be flow, and VPC and VPN attachments. VPCs and VPN connections can be attached to the transit gateway to enable the communication between the network. Each VPC can have one or more attachments. So one or more attachment you can create for one VPC. So what are the differences between here? The purpose, the connecting two VPCs directly, allowing them to communicate as if they were in a same network. That is called as VPC pairing. So if you go for the transit gateway, act as a central hub for connecting multiple VPCs and on-prem network, simplifying the network management. So network management is very easy when you use a transit gateway. And topology is nothing but a rules and protocols. It's point to point. So VPC pairing is a point-to-point, meaning each pairing connection is between two specific VPCs. So two specific VPCs, the connection will be established. And hub and spoke architecture. So what do you mean by hub? So it's a central hub, and spoke is your attached VPCs, where VPCs and network connected to the transit gateway. Scalability, limited scalability. Each VPCs can have a limited number of pairing connections. It's nothing but only few pairing connections you can use. You need to ask with your service provider to increase the limit. So high scalable, capable of handling large number of VPCs and networks. So complexity can become complex to manage with many VPCs due to the need of multiple pairing connections. So if you have more VPCs, then you need to create more pairing connections, so that it will be very difficult for you to manage, where you're simplifying management compares to managing numerous VPC pairing connections. Okay. So next is cost. Generally, more cost effective for connecting a small number of VPCs can be more expensive than VPC pairing for simple scenarios, but offer cost saving for complex large scale deployment. If you are going for the large scale deployment, then it allows you a savings. But if you are using this transit gateway for the small network, then it will be expensive for you. So if you are using a small network, then VPC pairing is the best solution. If you are using for a large network, transit gateway is the best solution. Why? Because here you will be saving the cost. So here the cost will be affected on the pairing, number of pairing connections which you have established. If you have less number of pairing connections, then you can go with VPC pairing. If you have a large number of pairing connectivities, then you need to go with a transit gateway. So use cases, simple scenario like connecting a deployment VPC to a production VPC, or sharing the resource between the two VPCs. This VPC pairing will be sufficient, but connecting multiple VPCs across different regions or accounts, connecting VPCs to on-prem networks, and supporting complex large-scale network architecture. So if you are connecting your VPCs from one region to another region, from one account to another account, like let us say I have my account and I have a customer account. So I want to establish a communication between the customer account and my account. Then I need to create a VPC pairing between both of them. So at that point, I require a transit gateway which establish a communication between the customer account as well as from my account. So it's a large scale networking architecture. So for the large scale networking architecture, we will be using as a transit gateway. Okay. Next. So till here it's clear about transit gateway, right? So is it everyone clear about transit gateway? Then I will start with the net. Yes, thanks, Fahid. Can I have a reply from others also? See, these are the networking concepts which are little bit typical ones. Just you need to pay attention. Just go through all the video sessions which we have started from Monday, Tuesday, Wednesday. So all this contains about it's a networking concept. So just you go through the videos one by one, and try to understand it. So it is very easy. I am explaining you in a very easy manner. So I'm not making this as a complex. I'm not using different regions, and I'm not creating any routes over there. I am using only one region to understand. Once you understand all these concepts, once you are clear with all the concepts, try your own methods. So let us say I said like we will be using transit gateway, will be using for a multiple regions. So in your lab sessions, you try to use that multiple region concept and try to establish a communication. That's what I want you to do, the lab sessions. Not only I don't want you to do only the sessions which I have explained you, I want you to do all other sessions also which I have not explained you. Okay, so based upon these basis, you can explore more things and you can do more labs. So I suggest you to do as much as lab. Like here we are doing a 2 hours of class, but I want you to do the lab as much as you can, like 4, 5, 6, 8 hours also it is good. So once if you do more labs, then you will understand more topology. I agree that there may be a difficulties or challenges which you will be facing during the lab, but try to troubleshoot it. Error message, see the error message, go to the logs, event logs, like you have a trial CloudWatch and CloudTrail. So go to the CloudTrail, and there you can find all the logs for all the related VPCs and all. So just try that, and you will get an error. Try to Google the error and try to fix the error. Okay, so that's what I want you to do. Why? Because our job as a system administration job is to troubleshoot and fix the issue. So you can only troubleshoot and fix once you understand the scenario. So just try to understand the scenario and try to fix the issues. Okay. Okay, let's come to the next topic, that is called as NACL, that is called as Network Access Control List. So this is nothing but it says simply, as I discussed earlier, NACL is a one type of firewall or one type of security firewall which allows your inbound and outbound traffic. So inbound is nothing but the traffic which comes from your outside network, outbound the traffic which goes from your network. So here NACL can be applied on a subnet level. There are two types of security firewalls in AWS. One is called as NACL and another is called as a group policy. So NACL, the differences between both of them is nothing but NACL is applied on a subnet, and group policies is security group. One is NACL and another is called as security group. NACL applies on subnet and security group applies on EC2 instance. So here these is the differences, and another major difference is you can deny in your NACL, but you cannot configure as a deny in your security group. You can allow the ports, but you cannot deny it. Okay, so but deny can be made or can be processed through an NACL only, and every VPC have a default NACL which says that everything is allowed, so nothing is denied. So here NACL controls inbound and outbound traffic of a subnet level with your VPC. It lists the rules that specific what type of traffic, incoming or outgoing, is allowed to flow through based on the criteria like protocol, ports, source, and destination address. So it based upon these criteria, what are the protocol like TCP/IP and RDP, SSH. So these are the protocols, and that have a default port numbers. So you need to specify the port number and what is the source and what is the destination. Based upon that only the NACL will work. If what is the incoming and what is the outgoing traffic, it based upon that criteria only your NACL work. So each AWS account includes a default NACL which allowed all inbound and outbound traffic, but you can modify it by adding your own rules. By modifying, you can modify the NACL role, but by default it is all allowed inbound and outbound. So when configuring your VPC, you can use your account's default network NACL or create a custom NACL. You can also create a custom NACL, and you can attach that NACL to your VPC. Okay. Custom NACL, all inbound and outbound traffic is denied until you add the rules to specify which traffic to allow. So here there is some differences. The default NACL which have all inbound and outbound traffic is allowed. Okay, so that is a default NACL which is assigned to your default VPC. If you create a new NACL or new custom NACL, so once you create a new NACL, all the traffic for inbound and outbound are denied. You need to modify it. Okay, so and NACL perform stateless packet filtering. So what do you mean by stateless packet filtering? Let us take an example. So you kept a door in front of your house. Okay, I came to your house and I ring the bell. Okay, so I ring the bell and the person comes from a home and he asks me, who are you? then I will give my information. I will give my identity. So, hi, I am so and so. I am so and so. So just allow me. So that is nothing but inspecting a packet header information. So that is nothing but it inspects your packet header information. So every information from the source, what is a source, what is a destination, and what is a protocol, and what is a port, everything is mentioned on your packet. Packet is nothing but your data. Your data is wrapped in the form of packet, and that packet has named some information on your packet, which is called as your header. Packet header information will be inspected. So okay, I came to your home and I ring your bell. You came and asked me, who are you? I explain everything, like I am so and so, I am so and so, and so and so. Then so next you will verify whether, okay, yeah, Farooq. So should I allow him or not? You will take your list from your list table or your control list table and see that yes, Farooq is a member of this house or not. He is not. He is a guest or what. So which type of permission he need to be allowed. So based upon that list, you will compare the packet, who the person is or how the packet is there. If the packet is authorized, if the packet is authorized to allow, then it will allow the packets. The same scenario will happen once you go out also. So it will, once you come in, it will inspect everything, and once you go out, it will also inspect everything. So in and out inspection is nothing but stateless packet filtering or stateless firewall. We can call it as stateless firewall. So it will inspect everything based upon what need to be come in and what need to be go out. Means it is very secure firewall or stateless packet filtering. It's nothing but it's a secure firewall. Whereas security group is stateful packet firewall. So what do you mean by stateful? So we have two types of packet firewalls. One is called as stateless and another is a stateful. Stateless, which will analyze each and every concept, which analyze each and every packet which comes in, and it verifies your route table, and then it will verify whether it should be allowed or it should be denied. So if I mention a rule, if the request or if the traffic comes from particular packet or particular source, you deny that deny that packet. Then based upon the rule, if it is allowed, then I will allowing it. If it is denied, I'm denying it. So the same condition happens vice versa from input for incoming and outgoing. That is in a stateless packet. For for stateful packet, stateful packet is will recognize and will keep the information with him. Let us take an example. Hello, I came to your home and have ring the bell. Okay, and I said, okay, I am so and so, I am so and so, I am so and so. My name is Muhammad Farooq. I am from coming from this place, and this is my identity and this is my information. Okay, I given all this information. After suddenly I says that, okay, I have given all this information. I will be coming back after some time. Not right now. I'm not going to come in right now. I will be going to come in after some time. You will say, okay, you come after some time. Then when I come for the next time, then you won't ask any information. Why? Because already this information I have given to you, and that you have already stored. So that is called a stateful packet filtering. So stateful packet filtering, which will identify which identifies your information and stores in your in your bucket, and it will not ask you for the second time. But here the stateless packet filtering, it will ask you for each and every time whenever the packet comes in. Whenever the packet comes in or whenever the packet goes out, it will ask for each and every time. So that is called as a stateless packet filtering. Whereas, so if you have an interview point of view question, you need to tell that the NACL is a stateless packet filtering firewall, and whereas the security group is stateful packet filtering firewall. Okay, this is a major differences between the stateless and stateful. Is it clear with everyone? Modify the screen. Okay. Is it okay now, Mohammed? Okay, let us see the difference between your security group and NACL, it network access control list. So operate at instance level. Security group, it operates on instance level, and your network access control list operates on a subnet level and applies to an instance only if it is associated with the instance. If the security group is associated with a particular instance, then only it applies on your particular instance, applies to all instances deployed in the associated subnet. So in the subnet, any instances, it will apply on all the instances, not only a particular instance, but it applies on all the instances. Provide an additional layer of defense if the security group rules are too permissive. Okay, and supports allow rules only. You can see here it supports only allow rules. It won't support a deny rule. But here NACL supports both allow rule and deny rule. All rules are evaluated before deciding whether to allow the traffic. Here, we will evaluate whether it need to be allowed or not before allowing the traffic. Rules are evaluated in order, stating with the lowest number rule when deciding whether to allow the traffic or not. Yes, this is one more point. So that I will explain you at the time of lab session. Here in NACL, we will mention a numbers. Based upon the numbers, the traffic will be allowed or denied. For example, I have kept a number called as 90. In that 90, I kept a rule saying as a deny, and in 100, I kept a rule to allow. So which will be applied? The lowest number. What is the lowest number? 90. So first he will check for the 90 and he will deny the traffic. So he won't allow it. Why? Because the second rule is a allow. First rule is deny. So first rule is deny, then second rule it won't allow. So if you keep 90 as allow and 100 as a deny, then first it allow, then after it's deny. Means definitely it will deny. So when you keep the rule called as a deny, so that I will explain you at the time of creating a lab. So here the security group is a stateful group. Return the traffic is allowed regardless of the rule. So whatever may be the rule. So if you allow the traffic, then definitely it will allow your traffic. Whereas network NACL is a stateless. Return traffic must be explicitly allowed by the rule. So you need to identify, they will identify the rule, and if the rule is allowed, then only the traffic is allowed. Until unless if the rule is denied, then even though the traffic is identified, our traffic is identified as a secure traffic, then also it will deny. So multiple security groups can be associated with a resource. Means one EC2 instance, we can create and assign multiple security groups can be associated with multiple resource. But here multiple subnet can be bound with a single ACL. So one access control list can be assigned to multiple subnets. But here multiple subnets will cannot assign a multiple NACL. A single subnet cannot have a multiple ACL, but a one ACL can be assigned to a multiple subnets. Okay. So this is the difference between NACL and a security group. So today we are going to do this diagram. So we are going to create one AWS cloud, and we are going to do 3 private subnet clouds and 3 EC2 instance and 3 subnet IPs, and everyone has their own routing protocol. And here we will be creating a transit gateway. Okay. Here the first we will do is creation of 3 VPCs. One is VPC 1, 2, and VPC 3. Then we will create a. So I will do one thing. Sorry, I will paste this one. What we are going to do right now. Okay. So this is what we are going to do in a lab right now. Okay. So let us jump into the lab. Is it clear with everyone? Which one you want me to paste, Mohammed? Just a minute. Okay, thanks, Mohammed. And one more thing I want to share, like give your feedbacks on the sessions what you are going on right now. So based upon your feedback, like it will be helpful for me to understand whether you are able to understand or not, and how do I need to improve my, or do I need to explain some more examples for you to easy understand. So what I need to do that I can prepare and can get give you more clarity on more information on that. So just if it is good, then you can mention good, then we can continue in the same fashion. Okay. Okay, just give your feedbacks to me. Okay. So you can Alimuddin sir will be helping you how you can give the feedbacks if you don't know. Okay. Right. So now, first, don't be get confused. We will do lab very slowly. Okay. First, go to VPC. What is our first concept? As per the diagram, we need to create three VPCs, which is with 12, 13, and 14. Okay. We will be creating three VPCs. Just be concentrated. Go for VPCs. Here, let me select the region called as US East one. Okay, go for VPCs. Here, I don't have any VPCs right now. So I am going to select create a VPC. So here I am mentioning as test hyphen VPC hyphen 01. This is my first VPC. I am using an IP address called as 12.0.0.0 by 16. Okay. I am using this. Okay. And nothing I did, just I mentioned the name and I mentioned the CIDR value and I said create a VPC. That's it. So my VPC is got created. Okay. Next, I need to create another VPC that is called as VPC 02. Test hyphen VPC hyphen 02. 13.0.0.0 by 16. Okay. Next, come down. and say create a VPC. Now your VPC has been created. So VPC 01 and VPC 02 both are created. Now say create a VPC. Let us go with test hyphen VPC hyphen 0. Here 1 into 12, 13 is done. Now I am giving us 14.0.0.0 by 16. Okay. Come down and say creative. So here go for your VPCs. You can see you have 3 VPCs created. One is called as 12, another is 13, another is 14. So like this my VPCs are created. Now what I want to do, so I am assuming that my VPC1 or VPCA is a public VPC. Then for accessing a public VPC, I need a transit gateway. Okay. So our internet gate, sorry, not transit gateway, it's an internet gateway. Sorry, I'm mistaken. I said a transit gateway, but it's not a transit gateway, it is an internet gateway. To access my VPC, these three are the manual VPCs which does not have an internet connectivity. Just I will be using as internet gateway for one of my VPC. Okay. Let's don't we get confused. Here go and say create new internet gateway, and here it's IGW hyphen demo hyphen TG. It's nothing but transit gateway demo. So create internet gateway. Now I have created an internet gateway. What I need to do, I need this internet gateway need to be attached to which VPC? To this VPC 01, right? That is called as 12.0.0.0, right? Let us go here. Actions attached to a VPC. Now you can see number of 3 VPCs. I am attaching this to test VPC 01. So now I have attached my internet gateway to my VPC 1. What is my next step? I need to create a subnet. So go to subnet and say create a subnet. Here I need to create 3 subnets. Subnet 1, subnet 2 and subnet 3. Okay. Go for VPC 01. Here you can see your CIDR value. By default it's getting reflected. Okay. So I will say public hyphen VPC 01 hyphen 1A. Why I am using 1A? To know the availability zone. I am using in a availability zone 1A. The one subnet in availability zone 1A, and here I am using same CIDR value 12.0.0.0 by 24. So if I use 24, then my IPs are comes to 256 IPs. Okay, I can reduce also. That's all depends upon me. I am decided to have at least 256 IPs. Okay, don't be get confused. You can use multiple subnets. You can create multiple subnets. Like for one subnet I have used, that is called as public VPC01. I name this. I can use another subnet and I can name the CIDR value called 12.0.1.0 by 24 also. So like that you have a different subnet, but all comes into a single subnet. So say simply create a subnet. Now I have created a subnet. This subnet is associated with my test VPC01. So now I need to create another subnet which is for a VPC2. Create a subnet, select a VPC2, and here you got a CIDR value. Okay. So here I am selecting as private underscore VPC 02 minus 1A. Here my availability zone. Here I am using as 13.0.0.0 by 24. Okay. Say create a subnet. So I have created a subnet. Okay. You can see we have created two VPCs, right? Now you need to create another VPC. Go for create subnet. Sorry, another subnet. You need to create two subnets. Hyphen VPC 03 hyphen. Okay. 1. Availability zone 1A 14.0.0.0 by 24. Say created sub. What is left now? We have created VPCs. We have created internet gateway. We have created a subnet. And now the left part is RT, routing table. We need to create a routing table for each and every VPCs or each and every subnet. Go for routing table. Say create RT for VPC 01. Okay, routing table for VPC 01. Select this and select VPC 01. Say create a route table. My route table for VPC 01 is created. Okay. Go again for route table, create a route table and say RT hyphen VPC 02 and you select the VPC 0. Say create a route table. Go again for route table and select create route table. I am creating a 3 route tables here. RT hyphen VPC 03. Select this and select VPC 3. Now say create route table. So I have created now 3 route table, but I have not assigned or associated. These route tables are not associated with your subnets. You need to associate this with subnet. Select this route table and click on subnet association, and here select edit subnet association. You select the subnet which we have created. It's 12.0.0.0 by 24. This is a subnet which we have created, which is for your public VPC 1A. Select this and select save associations. Go for subnet association. You can see the subnet association. In the same way, you go and select for VPC2 subnet associate, edit subnet association, select your subnet private VPC 01 02 1A, say save association. Here I will be using as VPC3 subnet association, edit subnet, say private, okay, and now my routing tables has been created and the subnets are associated with the VPCs. Now the next concept is I need to update or I need to add a route of internet gateway. Which one is the internet gateway? VPC01 is a internet facing server which is called as a public server or public subnet. So I am selecting as RT VPC 01 and go for route, and here by default one route is created. I am creating as edit route now and say add route. So what one I need to add 0.0.0, and here I need to select as my internet gateway and the internet gateway demo. Okay, save the changes. Done. Fine. Till here, we are good with our network configurations. We have done all our network settings. We have placed our created VPC, subnets, routing table, internet gateway, everything we did it. So nothing is left here now for our networking part. Now you need to go with your EC2. You need to create an EC2 instance. Select launch EC2 instance. For VPC 01 I am using as server 01, and for the VPC 02 I am using as server 02, and for VPC 03 I am using as server 03. Okay, so server 01. And yesterday someone has asked that why we are selecting only Windows, can't we use a Linux? Okay, today in my lab I will use a Linux box. I won't use a Windows machine. Okay, let me use my Linux box. Okay, it's not specifically I am using Windows, but for some understanding purpose I used a Windows, but now I will use Linux also. Just let us see. So Amazon Linux, and here instance type and key pair I will be selecting as my key, my Linux web. Okay, anything comes to a network configuration part. Go for edit. Here I need to select VPC 01 is my server one, and here by default I will select the VPC public VPC 01 1A, and here I will enable an IP address. Okay, Then select this for identification purpose. I am naming this as server 01 security group. Okay. Only these are the changes I made. I selected under a VPC1 and I selected the subnet called as VPC01A and I click on launch instance. My instance is getting launched. Meanwhile, I will create another EC2, another instance that is called as server 02. Say launch EC2 server 02. I will use same Linux box. Come down, I will select a key pair, my Linux web. Go for now here edit. I will be selecting as VPC 02 and private VPC 021A, and I am not assigning any public IP address to this server. So click on launch instance. Okay, second instance is getting ready. Meanwhile, I will go and start another instance. Server 03. Here I will be editing it and I am selecting as VPC3 and VPC3 1A. I am not selecting any of the public internet. Okay. Say launch instance. For instances, let us see. Here, 3 instances are getting ready. My first EC2 instance already got connectivity, got a public IP address, and you can see the private IP address. It's from 12 series. So let me connect to my server 01. Say connect. You can see your public IP address and your private IP address. Let us go for server 2. You got an IP address called as 13.0.0.171. From this EC2 instance, say ping 13.0.0.0.171. I have run a ping command. Ping is a command to check the connectivity. I will say Control C. You can see here 45 packets has been sent, are transmitted, 0 packets has received, is 100% packet loss. It means that my communication is not established to 13.0.0.172. Why? Why? Because we have not created any pairing communication. Okay. Let us go for VPC. Here we have 3 VPCs. So what I will do now, go down, complete down. Here you see, you can see a transit gateway. Go for transit gateways. Here there are no transit gateway. Create a transit gateway. Okay. Transit gateway for VPC 01, VPC 02, VPC 03. This is my name of my transit gateway. Okay. Name tag, you can give the description, anything. I will give the same description. So here now you can see the configure the transit gateway Amazon side automation system number. So if you know the Amazon side system number, this is a default number which will be generated by your Amazon itself. Some around it will be around some, by default it's nothing but 6,50,000 something number will be there. But if you don't know, leave it blank. The Amazon will itself will create the number over here. No need not to do anything. So if you are want to configure the crossover sharing option, if you want to share your attachment, or if you want an establishment of communication between one region to another region, you need to select this. Okay. So I don't want to select this one right now. Or if you want a particular IP address need to be associated with this particular CIDR, need to be associated with this transit gateway, you can assign this also, but this is not required. So this is required at the time of your direct connectivity, AWS direct connect. So it's not required for me right now. So we will keep it as blank, and we will say create a transit gateway. Now my transit gateway has been getting created. It will take some time. Let's refresh it. Yes. Now my transit gateway has been created successfully. Now in the downside, you can see transit gateway attachment. You need to create an attachment for your transit gateway. Create a transit gateway attachment. Here I will naming as attachment hyphen 01. Okay, so this is for my VPC 01. So here that's the reason I am naming as attachment 01. Here you need to select your transit gateway ID which you have created just now. It's nothing but TG VPC 01, 02, 03. Select this. So here you can see the attachment type. So here once you click on this, you can see VPC, VPN, pairing connection and direct connect. So there are multiple types of attachment you can attach. So pairing connection also you can attach. Like once you say as a pairing connection, so you have my account or other account, you can select the region and you can select the acceptor transit gateway. Means at the acceptor side also you need to create one transit gateway. Now the communication will be happen between one transit gateway to another transit gateway. So here if you go for VPN, it will say existing, new or customer gateway. So that is nothing but your on-prem customer gateway or static IP address. Everything this outside IP address, this everything you need to provide. So tunnel is an optional. You can provide or not. It depends. If you go for direct connect, so connect attachment, select a transit gateway attachment. Here you need to create an attachment for your transit gateway. Then this can be selected by using a BGP. It's broad gateway protocol. So over here I am not doing anything. I will be selecting only a VPC. So here you need to select for which VPC you need to attach this attachment. So as the attachment is naming as 01, so I will be attaching this for my VPC 01 attachment. So once you click this, you got the availability subnet IDs for which we have created subnet. If I create for subnet for another subnet, by default it will be get enabled here. Okay, and this will be allowed. So I will be say create a transit gateway attachment. So it will take some time to create. Meanwhile, we will start creating another two attachments also. So every attachment we need to create a attachment. Like we need to create, if you go come to the diagram, we need to create one attachment, two attachment and three attachment. So three attachments we need to create. Attachment -02. So I will select my same transit gateway ID. I will keep it as VPC only. So this VPC attachment DNS security group, this by default it should be available. So here I will select as my test VPC 02. So by default I got the subnet mask. I will say create transit gateway attachment. Okay. I will go and create another transit gateway attachment. -03 VPC. Here also VPC as VPC 0. Say create transit gateway attachment. Now I have created three transit gateway attachment. under one transit gateway ID. So if you go for the transit gateway, you click on this, you can see the details. Okay. Transit gateway rule. See, transit gateway route table. It's by defaultly it is created. I have not created any rule or any route table. So by defaultly it has been created. If you select this route, you can see the associations. You can see now two transit gateway are attached. Two is not attachment is 31148C0 from VPC. You can see here transit gateway attachment 31148C0 and 3C2. Okay, these are the three attachments which need to be attached under my transit gateway route table. So if a route table is by default created, but if it is not created, you can also create by default. You can create manually by going for create route table, and you need to assign your transit gateway. Then it will be automatically will accommodate or associate with your attachments. So associates. So now you can see there are three associations which has been are three attachments. From here also you can create the routes, but little bit understanding it will be make some difficult for you. So I will not create from here. Okay. So now what I did, I have created the VPCs, created the subnets, created the internet gateway, attached internet gateway. Yes, Firasat. Hello. Yeah, Firasat. Can we create EC2 in multiple zones? Yes, Wahid, we can create EC2 in multiple zones, but the thing is that you need that zone need to be associated, or that you should have one subnet at least need to be associated with that zone. Okay. Go for VPC here. Okay. So now what I need to do, I need to create everything I have created. Only I need to create a route here now. Let us see here. Go to the EC2 instance and let me see whether it's getting ping or not. It's not getting ping. Let us see another EC2 instance. 14.0.209. Let us try to ping that also. The 20 packets transmitted, 0 packets received. So here it's not getting ping. So control C, 5 packets transmitted, 5 packets, 0 packets received. So now go for route table here. Bit concentrated on this part. So on a route table, in a route, okay, you need to create two attachments here. Okay. One is for your subnet 13 and another is for your subnet 14. Okay, for 13 VPC and 14 VPC, both are on a same attachment. Both will be transferred through a same attachment. So go for edit route, add route. Here 13.0.0.0 by 16. Here you select as transit gateway. So what is the attachment for a transit gateway? Here your attachment 01 is your transit gateway, and in the same way you need to associate with another IP address 14.0.0.0 by 16. Come here and say transit gateway and you attach this transit gateway. So two rules has been created. Click on save. Now you can see now you need to go to other route tables, that is called as 2. Here go for routes, say edit route, add route. You need to add a route of 12.0.0.0 by 16. Then you need to select your transit gateway and you need to select the attachment 02. Okay. Next, you need to select another transit gateway that is called as 14.0.0.0 by 16 and you select as transit gateway and go for attachment 02 and click on save the changes. In the same way, you need to attach your routing table or transit gateway to your another VPC. Go for route, go for edit route, add 12.0.0.0 by 16 and here you go with transit gateway attachment 03 and you need to add another one 13.0.0.0 by 16 transit gateway. Let's see. Now you have attached all the transit gateways. So you can see just verify it. So you are into a VPC route table VPC 03. Here you can see 12, 13, 14. All the networks are associated 12 and 13 from this transit gateway attachment. Come to 2. You can see here 12 and 14 is associated and come for 1. 12 is local, 13, 14 is associated with this transit gateway. Now go to your machine and say ping 13.0.0.171. So still not getting ping. Okay. What is the issue? Can anyone tell me? We have done all the configurations in a correct manner. We try for another IP address also. We have performed all these changes on a correct way, but still we are not able to communicate, we are not able to access, or we are not able to ping the server in different subnet. Can anyone tell me what is the issue we are facing? How you are going to troubleshoot? Okay. Everything I have done correct. I have not done any mistake. Everything I have done correct. I have not done a single mistake in here. Can anyone? Authentication? No. Authentication is not required. Just I am pinging it. Just I am checking the connectivity. I am not trying to log into the server. So if I want to log into the server, then authentication is required. So I am not logging on to the server. This is one of the troubleshooting which you want to do. Say, assume that this is the troubleshooting which you are doing in your live scenario. Someone, the user comes and says that I am not able to communicate with another server or another EC2 instance in different subnet. How you are going to troubleshoot? Think about it. I will give you another 5 to 10 minutes. I will give you 15 minutes of time for all of you. Just think it. We have done one small mistake. I know what mistake I did. NACL is needed. Why? Why NACL is needed here? As per the condition, all the NACL here, each AWS account includes a default NACL which allows all inbound and outbound traffic, but we can modify it. So default NACL is inbound and outbound, but here every VPC content. So every VPC contains a default NACL and default NACL which allows all inbound and outbound traffic. So once I created a custom VPC also, then a default NACL is got created. I need not to do any changes on that, but a default NACL has already created. But here, if I create a custom NACL, then it should be denied. But here, I have not created any customized NACL, then NACL won't come into picture, I think so. Wahid, just correct me if I'm wrong. Why you are saying as you say NACL? I want answer from all of them, whether it is correct or wrong. Wahid has given one answer. I was expecting an answer from others also. Just I will give you another 5 minutes or 10 minutes. Okay, you are asking, yes, you are asking, but you have assumed means something you have think it, right? So where the NACL comes into a picture. Okay, you have asked NACL is needed, but just you need to differentiate, you need to validate your answer also, why it is needed. So you need to justify your answer. Okay, you have said that NACL is needed. Okay, I agree, NACL is needed. Why it is needed? You need to justify it also. I want everyone please answer this question. Okay, whether it is correct or wrong. Good, Wahid, you have answered your question. It's good or wrong, whatever it may be. I will explain you why it is needed, where it is needed, and what is the mistake which we have done here, and how we can fix this. I will explain you. That's not an issue, but I want you to understand what mistake we have done. Just think about it. Just realize that. Just go through this diagram once again. So I will be keeping this diagram on this page. So just go through this diagram and let me know what the mistake we have done or where we have done any changes or anything mistake which we have done. Just let me know. Okay, I will give you another 5 minutes. Whatever it may be, maybe it is wrong or right, whatever it may be, just speak it out. Why? Because I want to understand. These are the major few concepts. It's a very tricky concepts, and this will be very much helpful for your real-time scenarios. When you are going to work in your real time, this type of issues you will face, you need to identify it, you need to troubleshoot it. This is a job of a sysops. Is nothing but we need to identify the issue, then only then only we can provide the solution. Okay, so just analyze it, analyze what I have explained and what we did and where we made a mistake and what we need to do. Okay, how we can fix it. Yeah, tell me, Wahid.
Sir, actually we have created EC2, but I think EC2 need to be assigned somewhere because we just created the EC2. We have launched that EC2 instance, but it is nowhere assigned in between. That was, I mean, I'm feeling that there is some connection required, I believe.
Yes, we have created EC2. Okay,
It is
but I did not understand what you are telling it. So we have created EC2, but I think it need to be assigned somewhere. So what you need to assign,
because our
right?
subnets,
You
our
are.
subnet, yeah, our subnets is within the EC2. So EC2 to subnet, there are no links
I
as
have
well.
assigned the subnet, right? So at the time of creating, I have edited the network configuration and I have made some changes.
But sir, we have created EC2 at the late stage, right? After launching EC2, we have directly went into Linux to check whether it is connecting to the server or not. But then
Yes,
after that,
yes. At the time of creation of EC2, see, let me show you. Let us go my EC2 instance, and here I can go with a networking part, and I can see that for the server 3, I have assigned as a VPC 03 and subnet. Let's come down. Let us see where interface. Yeah, see subnet also VPC 03 private 031A subnet. We have assigned the same subnet. That's the reason why we got the IP address of 14.0.0 to 209.
okay, all right.
But the mistake what we did here, we did not allow the protocol, right? We did not allow the protocol in the security group. So at the time of creating a security group, we did not allow any protocol. So let us come here and let us go for security groups. Okay, server 03 SG, and you have, if you go with server 03 SG security group, here you have only one inbound rule, that is called as SSH. So we are doing ping. Ping stands for packet tracing. So the packet tracing protocol is not allowed. So ICMP packet has not allowed from my security group. That's the reason why it's not getting communicated. It's not able to send the packet. Okay, if I do the SSH, definitely it works. Why? Because I am not doing an SSH, means I have allowed SSH. So I was doing an SSH. If I do, if I try to connect my EC2 instance, definitely it will get connect. But I am not trying to connect, just I am trying to ping it. So that I will create now. I will create a NACL. I will allow my ICMP packet through NACL, not through an security group. So if I allow the ICMP packet through an NACL, means all the systems in a particular subnet will able to communicate, are able to ping. Okay, ping each other. So if I allow on a security group level, then only a particular instance can able to communicate or ping. But other instances, for other instance also, I need to allow the ICMP packet. Okay, sorry again. So now I will go for NSCL here. So here, if we can go here on a left side in a routing table in a VPC column, you can see network access list. So click on network access list. Each and every VPCs, you can see you have three different VPCs which are associated with a different ACLs. Here you can see VPC 1A subnet associated, and VPC 3 1A, VPC 2 1A. So what I need to do here, a VPC IDs are also associated. Here you can see two inbound rules. So click on any one of the subnet or any one of the ACL. So here, if you can go here, you can see 100, all traffic, all ports, all are 00 allowed. So all are allowed here. Outbound rule is also all are allowed. So everything is allowed over here. So nothing has been denied. So star is nothing but a deny. Here I will go and select and edit inbound rule. Rule number is 100. Okay, all traffic. I will create an add rule. Okay, here I will mention as rule number 90, and here I will use custom ICMP allowed. Okay, I will click on save. Now my 90 comes on top. It's an ICMP packet, is allowed from all ports, and source is anyone. Okay, similarly I can also use to do in an outbound rule also. Edit outbound, say 95. Okay, ICMP. Here you can see allow and deny. So I click on allow and say save changes. Similarly, I need to do on other two ACLs as well. ICMP save changes. And outbound rule, edit outbound rule, go for 95. Here, select custom ICMP and say save. Still it's not working. Okay. Let's try to give it a security level group. Server 01. Yes, Fahid.
Sir, when we are using transit gate, we need to ignore a security group, right? Because it will supersede that, and that is the
Yeah, we
reason.
have not created anything on a security group, but
So,
we need to create it. We need to allow the ports. Why? Because we have using a Linux servers. So Linux servers by default we can do the SSH, but ping is disabled. So we need to allow that on a EC2 instance level also.
all right, okay.
Okay, so we need to allow at ICMP packets on both the levels. On NACL, it's all allowed, but there also we have modified some rule and we have made some changes. And parallelly, we also need to make some changes on security group level also. Okay, so let us come to security group. Here, I will go for security group Z1A. Here, add a rule. All SMP, custom, anywhere IP4, save the rule. Okay. Next, I need to go with server 02 also. Server 02 SG. Here also SSH is there. I need to allow my ICMP packets. Okay. On server 2 also have done that. Go for security group, server 03 SG. Click on this, edit inbound rule, add rule, save for ICMP, IPv4, and save. See, we have created now. So let us see ping. See, you have started communicating. The issue is that you have not allowed a ports. Okay, so you have started communicating. So let us say control C. So 13 packets transmitted, 13 packets received, 0% loss. So let us see whether we can communicate with 03 server also. Yes, we can also communicate with 03. The issue is with our security group. We have not allowed our ICMP packet in our security group. Okay. Let us see here. I have allowed here, right? So now what I will do, I will go to network, sorry. I will go to NACL, okay? And here what I will do is, I will deny it. I will deny an ICMP rule, okay? Here I will select this as a deny, okay? Then save. Parallelly, I will go for outbound. Also, I will say edit rule and I will say as deny and save the changes. Okay, let us do the same thing for the others as well. So right now you see that my EC2 instance is getting communicated, right? Let us see what actions has been taken. Okay, this is what NSL 2 I need to do, right? So let us see, Control C. Let us run again. You can see the difference. Now the packet transmission has been stopped. Even though I have configured my security group on my instance level, the ports are allowed, but on my NACL at the NACL part, my ports are denied. So that's the reason 26 packet transmitted, 0 packets received. So I will check for another server as well, that is called as 3. The same issue. Okay, for my 3 also it's getting allowed. Okay, I will do one more changes here. Don't be get confused. So I am doing some changes over here. I am going for VPC 01, that is assigned with my VPC public subnet. I am going as an inbound rule and say as edit. Okay, so I am creating an another rule saying as 80. Okay, custom ICMP packet protocol, and here the source address I am giving as 14.0.0.0 by 16, saying it as a allow. Okay. 14.0.0.16 as allowed. Okay. Here I am using as a rule number as 80 and deny rule number is 90. And here I am giving a source address. If any packet comes from a source called as 14.0.0.0 by 16, allow them. Okay. And an outbound rule also, I will give the same packet, edit rules, say add rule, say same 80, say same ICMP packet 4, and the destination is 14.0.0.0 by 16. I need to specify the destination also, saving as same. Now let us see some difference. Previously what happened? My packets which used to transmitted from 14.0 got blocked or denied. Now it should be allowed. I need some changes on the another side also, on VPC 3 side also. Inbound rule, edit, add rule, 80, source address. If the source address is 12.0.0.0 by 16, it should be allowed. And outbound, add a rule, twelve 12.0.0.0 by 16. It's not getting allowed. Why it is not getting allowed? Okay, so here, okay. Now I think I need to make some changes on deny also. Edit inbound. I will remove this. I will keep only the source as 13.0.0.0 by 16. And this. Yes, Vahid.
Sir, we have already created a rule 90, so that is stopping to go further to rule 80, it seems. Because already rule
Yeah.
90,
No, we have created a rule 90,
and
but here
which
you.
is denying,
No. See. Difference is there. So go for VPC 1 in inbound rule. It's 90 is denied. So here I mentioned as a source. So if the request is from 13.0.0.0 by 16, denied. If the request is from any other, allow it. So only I am giving an exception saying that the source is from 13.0.0. Any communication which from 13.0.0 you deny. Okay. In outbound also you can see you can allow everything, but you need to deny some rule. I will specify here add rule 90 ICMP 13.0.0.0 by 16 is deny. Yeah, let us go for two inbound. So 90 ICMP packet. Yes, Wahid.
Yes, sir. That one, the one which you deleted just now was a hindrance actually. I think I was actually thinking about that only, which you deleted recently now. Rule
Okay,
90.
you are saying about VPC 2.
Yeah, you just deleted rule 90 for some.
Okay, okay. VPC 2 I have deleted it. Let us
Yeah.
see. I think for VPC 2 I am removing all the rules. Okay. And for VPC 3 also I will remove all the rules. I will keep that default. Let me check. Okay. See now 14.0.0 is start communicated. Only 13.0.0 should not communicate. Apart from that, it should communicate with all others. So the source address is the destination address. Here, if you can go here and you can see in your NACL, which is assigned to my VPC01, that is public. In an inbound rule, I mentioned a rule, ICMP packet, which the source is 13.0.0.16 should be denied and all other traffic should be allowed. Okay. First, it checks for your 90 port number, rule number. Then it verifies the source, and if its source is matched, then it will check for your condition what you need to do, allow or deny. If it is in deny, then it will be denied. So then when once if I am doing a ping for 13.0.0.0, then it will check this rule first, and here it find the source address is 13.0.0 and the action is denied. So that's the reason it got denied. So when I say the IP address 14.0.0.0.209 and say enter, so here what this rule is doing, so this rule is going and checking the 90 port number 1, and he's saying as this is source address is not got matched. The source address is not get matched. The source address is 14, but the deny rule is for 13. So he will skip this one and he will go for the second option, that is called as 100. Here all traffic allow 000 from any source, it's allowed. So then it's allowing, it's getting communicated. So this is the advantages of your NACL, where you can deny or as well as you can allow, but these deny and allow cannot be possible on your security group. Here on your security group, just you can mention the source address and destination address and your protocol and your port range and your type of packets. That's it. But allow or deny is not applicable. Means whatever you create here, that simply says it's allowed. So deny condition is only not deny condition option itself is not there for security group. But for NACL, you have two options: allow and deny. You can allow or deny on a security level, on a NACL level, but on a security group level, only you can allow. Okay, here I have allowed ICMP packets, but see, for this all the three instances, I have allowed ICMP packet, but I have denied on my NACL. So that's the reason it's not getting communicated to my second server. That is on 13. See, this is the difference. Okay, it's clear now. Or do you want me to explain this once again? Don't be little bit get confused. Just watch this video and see the settings and do as it is so that you will understand. Whenever you are doing a lab, just use the same names so that you will get identified and easily you can troubleshoot it. Okay. Okay, is it clear? So hope everyone is clear with these topics. Okay. Okay, thanks. Thanks, Mohit. So I hope everyone is clear with this topic. Inshallah, we will meet tomorrow with the new topics. Okay. Till then, goodbye, good night, Allah Hafiz. So do the lab sessions, do the practicals. Okay. ICMP is a packet transmission. ICMP is there is some full form. I didn't remember. Let me check. ICMP is a packet transmission. Yeah. Inter-control message protocol. It's a protocol. Internet control message protocol. I did not. I forgot the name abbreviation. Okay. Okay. So good. Meet tomorrow, inshallah. Okay. Till then, goodbye. Okay.